Hello, thanks for joining me. Today we're going to be going through my Kunray 3000 watt 72 volt gold cart project. It was a Carter Superwheels, and we're going to make an electric go kart out of that. So stay tuned. There's an enormous amount of content, so enjoy. The presentation is about 45 minutes long. So this is designed for somebody who wants to know how to do this from start to finish. There will be a part 2 of the video where there's actual driving and speed tests and things like that. That will be posted separately. So let's get to it and buckle up. So why did we choose electric? Well, other than the obvious, environmental concerns, they're quiet, they're eco-friendly, and only cost pennies to charge. They're fun to drive, and they don't stink and smell, and they're not loud. And the big reason is that we live in an HOA like most people do, and we're not rural in any way, shape, or form. So we had there's a covenant in our HOA that allows electric scooters, electric golf carts, and electric fill in the blank sort of things on designated bike paths in our subdivision. So if we went with gas, it would obviously be a lot cheaper, but we really couldn't do it anywhere. So we have this designation with the Texas Department of Transportation called NEVs, Neighborhood Electric Vehicles. And if they have a certain piece of equipment on them, you can actually register them. So that's why we ended up going this route. The cons are it's pretty expensive. It's about 2 to 3 times, or maybe even higher, if you're trying to duplicate the same power as a gas engine. For frame of reference, you can get a Harbor Freight 6.5 horsepower Predator gas engine for $99 with a coupon. But this ended up being, as far as total solution from stop to start, was probably about $1,000, and we'll get into that. It's obviously a lot more complicated, and if you're building your own battery pack or wiring up everything from scratch and it's not a kit or a conversion, the skill levels required can be pretty high. I'm pretty good at fixing stuff, and I have an electrical engineering degree, but that shouldn't stop you from being able to do something like this as well. I'm sure many people have done it. So let's get going. From here on out, lots of pictures, some text boxes, things like that, but there's going to be a lot of content that is detailed that I'm not going to have text boxes for, and some of it's actually significant safety information, especially when we get to the battery discussion. So please listen to the audio as well. So first of all, I don't know how to weld, so I just had to find a frame first. So I searched around Craigslist, and I found this nasty, rusty, whatever, go-kart frame sitting out in someone's backyard. And we drove out to go get it, and it was $25. So I'm like, this is great. I can't go wrong. There's more than $25 worth of scrap steel there, in my opinion. So we brought it home, and I started sanding and power washing and things like that. I'm like, yeah, this is too much. I'd rather just take it to a powder coating place, and let's do it right. I'll make it look brand new. So I was able to find some pictures on the internet. Apparently this is probably what it looked like when it was new at some point. Gorgeous, absolutely gorgeous job. Went to Flaming Dirt powder coating place here in the Dallas area, and Ken did a great job. Sandblasted and bead blasted, painted the frame a nice gold, as well as the seat was a matte black, and I just spray painted the steering wheel gold because that's what my son wanted. It was $255 for that, which now we're starting to spend some money. But the bottom line is that powder coating is superior in every way, and I didn't really feel like spending the time to sand it, paint it myself. And this is a much better looking job. Some terminology. Note that this is a dead axle go-kart frame. What's a dead axle? It's a steel bar with, in this case, 5/8 inch hex bolts welded to the ends of it, and those are your axle spindles for the rear. As opposed to a live axle, that would be a rotating shaft with bearings, and probably a disc brake or something. So with this setup, it's one-wheel drive and one-wheel brake, and this is the plate for mounting the gas engine. The good part about it is that once we started power washing, I uncovered a sticker on the back, and it said Carter Brothers, and I've never built a go-kart before, so I just had to start digging around. I found a company called BMI Karts and Parts, and I went through all their model numbers, and apparently they had all the blueprints for all of their models of Carter's go-karts online and parts lists. I'm like, this is great. I got a frame, I got a exploded drawing, I got a parts list, and I was able to identify this as a Carter Superwheels. This designated as a lawn cart. It's a two-seater, but it's not like two adults; it's two kids. As far as that size goes, it's smaller, but for what we're trying to do, it fits the width of a sidewalk. It's perfect. It's awesome. So. The stock wheel size in this was 4 inches, but actually it's 5 inches. We wanted to go with the 6-inch to get a little more ground clearance. So let the ordering begin. Here we go. So this is what I thought we would need to get to a rolling chassis. The 5-inch brake band and drum were not available at BMI, so I ordered those from Go Power Sports on eBay here in Texas. Got those in. I did not order a brake rod. We'll talk about that. I ended up making it myself. So I ordered 2 back wheels. So what are we up to? 253 plus 255 plus 25. So it's 500, 525, 575, plus 2 front wheels. Probably about $600 for a rolling chassis right now. That's kind of where we're at. So the next image. Awesome, amazing. Now the 2 front wheels are Harbor Freight wheelbarrow wheels. They are not go-kart wheels. They're not dual ply, and they are absolutely not holding up compared to the 2 back wheels. We've been riding it around for about a week, and the tires are almost bald up front. And we'll get into that later in the live video as well. I had some extra LED work lights that were inside of the trailer back here. I took those out and mounted them as headlights here because I figured it'd be cool since once we decided to go with electric. Down here we noticed we put some I put some of that foam anti-fatigue floor mat, whatever, just cut the shape with scissors, so that looked kind of cool. Plus allowed me to hide the wires for the headlights underneath, hide the wires for the throttle pedal cable as well. So pretty slick. So we got a rolling chassis. Next choice is like, how are we going to power it? What are we going to power it with? Oh, side note here before I get onto the engine part. Carter Superwheels frame. The spindles were the spindle brackets were 1/2 inch. So I could have purchased the 1/2 inch spindle brackets online. They were at a premium because apparently Carter went out of business around 2005-ish or so. So I figured I would just drill out the brackets to 5/8 and just use off-the-shelf spindle brackets from BMI. And it worked great. Oh, yeah, we painted the wheels black. Looks cool. Oh, yeah, if you want to see, notice we're already seeing tire wear on the fronts. It's amazing. All right, so as far as power, why did I choose this? Well, the inspiration for our project was really there was a video, a really, really great video. Someone built a 1,800-watt electric go-kart for their kid, and they made it out of PVC. Painted it black, looked like a little mini Batmobile, had a USB charging port, a battery box with fans, and whatnot. And I'm like, well, this is great. He had the little speedometer app on his phone. It was in kilometers an hour. It wasn't a full-speed run. So I don't really know, what that maximum speed was. So I didn't really have a frame of reference. Plus, this is a steel frame, and my kid's a little older, he's a little bigger. I was concerned that if we went with the 1,800 watt and it wasn't fast enough, then we will already be looking at trying to upgrade it. So, and this is what really blew our budget out of the water, is doing this, is going to the 3,000 watt. But I'm glad we did in hindsight, because it actually ends up being pretty amazing. This is There's 746 watts per horsepower. Your standard go-kart like came with back in 2005ish or so, the Carter Superwheels. It had a Tecumseh 5 horsepower or whatever, but any Briggs and Stratton or Harbor Freight would bolt right on the 5, 6.5 horsepower, whatever. But there's losses. There's losses from it doesn't run on the same RPMs. There's losses in the centrifugal clutch, whatever. But this is it looks like a clean 4 horsepower, instant torque immediately available. This should be good enough. I don't know. I had no idea. I've never built one of these before. So we went with the biggest motor that we could find of the Chinese line before you start getting into the giant golf cart motors or forklift motors. Plus it came with the pedal and the key lock, which I thought was nice. So I'm like, how fast is it going to go? I have no idea. Again, I've never built one of these before. So my BMI had this really nice speed calculator. You put the drive wheel diameter in inches and RPM, and your axle and motor sprocket teeth. So we had a 10-tooth sprocket on the electric motor and a 60-tooth sprocket on the rear wheel. That's a 6-to-1 gear ratio. And the wheel diameter, actually there's 6-inch rims, but the wheel diameter for this is supposed to be from the bottom of the tire to the top of the tire. And you get about 2 inches on either side. So it's about 10 inches. And so that came out to 25 miles an hour. That'll work. But I want to point out this has nothing to do with horsepower, nothing to do with torque, nothing to do with weight, nothing to do with friction. This is just a geometry problem. This is pi r squared with a 10-inch diameter circle. When you roll that circle out on flat land, how much space is that? Multiplied by 5,000 divided by 6, and that's all this is. There are other sprockets available. There's a 60-tooth, a 50-tooth, and a 40-tooth, and those are these speeds that I calculated accordingly. Now, I bought the 40-tooth, and I did not hit the 37. These are theoretical. I did hit the 25 exactly with the 60, and I feel like that there was more meat on the bone on there because the current draw wasn't that great. But we'll get to all that during the live video in part 2. So 40 might have been a little too much. So, but point being is that this is just a geometry problem and nothing else. Now we can talk about torque a little bit. So this was the chart. So it looks like with this motor, a maximum torque at maximum RPM looks like it's about 5.5 newton meters. I don't know what a newton meter is. American. Actually, I know what a newton meter is, but I don't have any frame of reference. So I just wanted to convert it to foot pounds. There's 33.3 inches per meter, 12 inches to a foot, 4.45 newtons per pound. You mix all that up and put it in a blender on high, and you come out with 0.74. So 5.5 newton meters is about 4 foot-pounds of torque at max RPM. And this is where it starts to get interesting. So this was a nice little calculator I found. So the long and short of it is, when you have a 6-to-1 gear ratio, or 0.7-to-1 if you inverse it, you have a mechanical advantage, a force multiplier of 6. Sounds military. And that being said, if you've got 4 pounds in on the motor shaft and you've got a 6-to-1 gear ratio, you've got 24 foot-pounds of torque at the rear wheel. That should be pretty good. It's pretty good from what I'm thinking. Now notice how the torque drops when the tooth count decreases. So your speed goes up, but your torque goes down. And like I said, I tried the 40 tooth. I have a video of that. I'll show you. 16 foot-pounds doesn't get you moving very quick, and you're probably not going to be able to climb any hills or any inclines. So, but we'll get into that. That with the 40, you might end up, it was an excessive load on the motor, extra heat, excessive current draw. without even reaching the 37 potential. So my gut is saying that the 50 tooth is the best balance. I got to 32 with the 40 tooth, which means if I with the 50 tooth, I'll probably still get the 32, but I won't have the load or the current draw to go along with it. Since I actually hit the exact 25 miles an hour with the 60 tooth, the calculations were perfect. Okay, let's get started in the build. This slide I like to call, oops, the motor won't fit. Well, there's the plates designed for a gas engine sits up a lot higher. So this was before. Now I could finish the go-kart, and I could stand on the back and hold the motor up for my kid while he rides it. That probably won't work. So I threw this drawing together, and I needed to go up 2 inches and over 2 inches, about somewhere in that range. Found a local welder, zip, zam, zoom. Next day, we go from me holding the motor up in space to a drawing to this right here. Beautiful, absolutely perfect. Well, it really wasn't. It wasn't perfect because here's why. Did it solve the problem? It absolutely solved the problem. But the issue is that I undersized this bracket by at least 2 inches in width on the top plate and the bottom plate for that matter. And you say, well, why? It fits perfectly. It does, but right here, I had to drill. I'd use number 14 self-tapping screws. When the motor was sitting on the plate, it didn't come over on this side or on this side or on the outside of the bar in order for me to use nuts and bolts. And the other thing it didn't allow me to do, it didn't allow me to cut slots in this anywhere so I could adjust this thing for chain tension. I can't move this around. I can't move this around. My only option is to stack washers. Not ideal. That'll work, but it's not exactly the best design. So while this was a win, it was not quite correct. So you have to fit the chain without any stacking washers, make that as tight as you can, and then shimmy some washers underneath there to tighten it up. That works, but like I said, I would have liked to be able to just loosen the bolt and slide it over to tighten it up or whatever. Brakes. Okay, so brakes. Well, the electric go-kart, scooter, e-bike conversions have e-brakes, which just dumps a small reverse current load to the controller to add friction so that the vehicle can slow down. I didn't use the e-brakes because I didn't know if I could use a foot pedal for that or not. Since I already bought the brake band and the drum, I happen to have a 4-foot-long piece of 1/4-inch steel rod. I had a blowtorch and a little propane torch, and I heated up then until it was orange, and banged the you-know-what out of it till it was flat, and then bent the rod to fit and put some bolts on it, and it works fine. Just keep it simple, and it works great. My son slams on the brakes, it sounds like a car slamming on its brakes. It even makes the same sound. So that solves the problem. I got a generic return spring. I had to put a little bit of a bend on it to get some more tension so that the brake would push back all the way. It's actually a simple solution, all set. And probably should paint the brake rod though. All right, so here we go. Now we're cracking. Cooking with gas here, pardon the pun. It's actually electric. Now we're cooking with electricity. I got a 3/4-inch ply exterior plywood board, and I cut it to fit so that I had a platform with which to mount everything. I started mounting things, starting hooking up wires, and as far as this battery here, just pretend you haven't seen that yet. That's a whole another discussion. It's kind of a big deal. So, but for right now, we started wiring things. Here's your pin diagrams, battery, motor phase, power lock. Power lock, that's your key lock. That's what that goes into. High level brake didn't use. High and low speed, that's a 3-position switch. Okay, click, click, click. If you do not put a switch on this, then the default speed is medium, not high. Just note that. So you're going to need to get a 3-position switch and wire it up accordingly. Cruise. The cruise actually works. Really cool, folks. Having cruise control on a go-kart. I think that's slicker than you know what. This is the hall sensor. Reverse works fine. Just note that your throttle is limited to 50% when you're in reverse. Throttle, that's the 0 to 5k ohm throttle pedal that came with the kit. Low level brake I didn't use, anti-theft didn't use, anti-theft power supply didn't use. This one, hard boots. Leave this disconnected. Leave this disconnected. You only connect this if you're troubleshooting. Other than that, all this other stuff, tape up, curl up, ball up somewhere. Don't cut it off. You may use it someday. But these are the things I didn't use. All right, connecting the chain. This is where the American-Chinese battle rages on. You got two choices here, folks. You got a Chinese motor with a Chinese T8F metric sprocket, and you've got an American wheel with an American number 35 sprocket. Your choices are find an American sprocket that fits on this shaft of this electric motor, or find a 4-bolt hole patterned T8F sprocket or some other size 25. You can find 25 here or 25 here or 35. Find the sprocket that fits the rear wheel and matches the bolt mounting pattern of the BMI Kart's split rim and standoff. Through many purchases and returns, I learned the hard way, but I ended up going with the motor sprocket. Very important. This 10-tooth, 10mm double D, this is the only one of its kind, folks. There are no other options. There are no other places you can get it. There are no other tooth count options. There is nothing else will fit. Nobody makes anything else. This is the only place. And for $10, you better grab it. And that way it's easy breezy. You already got the wheel. You already got the number 35 chain. You can change these sprockets if you want different speeds. It's a little more difficult than changing sprockets here, but at least we have a solution. And I got some roller chains, number 35. I got this chain breaker. It ain't that great. It works, but I prefer a chain breaker that grips over both sides of the chain link. Otherwise, you see it's gripping right here underneath the middle there, and then when the pin gets pushed out, it starts to bend out the chain right here. It screws it up. So when all is said and done, I fit the chain. As you can see, I've got stacking washers here to make it nice and tight. So let's back up with the wiring. So there's no way I could leave it like this. Like I said, never did this before. So I needed to build a battery box and hide all of this because I can't have kids running around with 72 volts and 50 amps of exposed electricity for kids to get in trouble with, or it gets rained on, splashed on, whatever. Everything needed to go into a battery box. Okay, so next time it was time to test the motor, which I like to call this slide, hey, let's drive in reverse all day. So, you need to listen very carefully. This motor was set up for a mid-drive application. What does that mean? It was set up for a situation where the motor was facing the other direction, spinning clockwise. Okay, now this was mounted off to the side, so it's spinning counterclockwise with respect to the left side of the go-kart. And when we tested it and stepped on the throttle, it started spinning backwards. Now, back from my RC days with brushless motors. Now, brushless motors are not DC motors. You could switch any two of the three, and it would spin in the other direction. That's the case here, but you still have to do one more step. So I contacted Kunray, and they told me to switch the blue and the green phase wires. As you can see, I did that here. And then you take a small pin or jeweler's screwdriver inside the connector of the hall sensor wire here, and push out the blue and the blue wire and the yellow wire, and then switch them. So switched here, switched on the hall sensor, everything was great. I thought originally I could just leave it the way it was and just switch the forward and reverse setting. Well, that worked, but then you only get to drive in one speed at 50% throttle. And that obviously wasn't going to be a solution if I wanted to drive in reverse with 3 speeds at 25. So that was not going to work. So this is the only way to really fix that issue. One thing I do want to note, going back to this right here, now that the motor's spinning in the right direction from our perspective, this is really important, folks. You need to listen. because of that, because we reversed it, this nut, and because of the torque of the engine, this nut wants to unscrew. It doesn't want to screw on tighter. It wants to loosen. Okay, I almost lost this nut and washer from this, and so you need to put some thread lock on it. Blue thread lock would be good, preferably that, not the red, otherwise you'll never get it off. That's a 10 millimeter crescent wrench and a 12 millimeter crescent wrench, and crank that baby on, and then you shouldn't have any more issues. But again, it does want to unscrew as you use the go-kart. All right, here's the doozy, folks. I'm going to talk a lot about this because it's pretty crazy what I decided to do. A 72 volt, 20 to 40 amp hour battery is anywhere between $500 and $700, maybe more, maybe even $800. Maybe I think a 40 amps $1,000. We're getting out of hand with our budget. I didn't think about the battery cost as much, considering I had to get as much as 72 volts. So I went to Battery Hookup and I sourced these used 7.2 volt Nissan Leaf battery modules. I'm not going to go into the discussion of how to take these apart. There is a video out there, so go to YouTube and Google, or go to YouTube and search Nissan Leaf batteries, and there's a 3-part video of someone explaining how they opened this up, how they got these tabs separated, and what they needed to do. Did I need to do this? No, I did not need to do this. But if I didn't want to do this, I had to buy 10 of these, and that was $500. That was still cheaper than buying a retail battery, but we're also talking about 64 amp hours of capacity and a significant amount of size and weight for amount of range that was ridiculously unnecessary. So if I contacted them and say, listen, these 7.2 volt batteries, can I open these up and convert them to 14 volts? And they're like, yep. I said, how do I do it? And they're like, we can't tell you. We can't have that liability. I'm like, okay. So that's when I went to YouTube. So I opened these up with a tin can, and there's these metal tabs right here. These are the bus bars that connect. There's 4 cells in each one of these, and they're set up. 2 of them are in series, 2 of them are in parallel, and that makes 7.4 volts per module. I needed them to be 4 in series, which would be 14.8. What does that mean? It means that I'd only need 5 of these things to get 72 volts instead of 10. And so that'd be 72 volts at 32 amp hours, which is still a significant amount of stored energy, about 2.5 kilowatts of power on the back of an electric go-kart for a kid. So this was exhaustive. It was risky. There was the opportunity to short circuit with the soldering iron, an opportunity to burn yourself pretty bad, because quite frankly you are not going to be able to solder these tabs on the batteries or 8-gauge THHN copper wire with a regular soldering iron. You're going to need at least 150 to 200 watt soldering iron, and it's a big boy, and it gets hot really fast, and the tip is pretty wide, and there's a lot of opportunity to short circuit. I actually had an accident where I had a short, and it almost welded a Craftsman socket wrench to the frame of the go-kart. So, and it looked like I'd stared at it was a blinding flash, like I'd stared into the sun for 5 minutes. So a lot of juice here, folks. Really careful. If you're not comfortable with this, I would suggest just buying a retail battery pack. So, but when all is said and done, for me, was it worth it? It was absolutely worth it. It was $250 for these 5 modules, plus the copper wire, and I had to buy a soldering iron and whatnot. So I still thought it was worth it. But I also wanted to preserve the casserole dish cans or their cover containers, so I can put threaded rod through these and compress them together and make it secure. I can't have this stuff moving around. I had to Dremel cut these bus bars, Dremel cut plastic, take out this battery management thing here, tab in the middle, and just make it looks really messy, but I put foam and plexiglass and liquid electrical tape anything I could, duct taping little pieces of plexiglass in between the sandwich layers so nothing touches, because I had to go and make these connections to make them serial so that I could get that amount of power. It was a lot of work, and it was very time consuming. But then all this went into the battery box. I had threaded rods that went through the battery box and through the bottom base plate of the wooden base plate of the back of the go-kart with T-nuts underneath, so that when I bolted this in, is in the battery box, and the battery box is on the base plate. It is not going anywhere. It's very secure, and I feel very safe having that set up like that. So I spent a lot of time with this. So I'm just saying this is a lot of work to do this, but the amount of power and range that this go-kart has is ridiculous, actually. And those battery cells are about 8.5 by 11 each. They're about inch thick, so pretty compact. So it's got about the same weight as one marine deep cycle battery, but 6 times the energy. I bet you could probably start 6 semi-trucks at the same time with this. So here's the giant soldering iron, 200 watts. Actually, 200 watts is a little bit big, but you need it. You're going to solder that big of wire, and it does work. I'd actually almost suggest getting a dimmer, a 200-watt dimmer, and just dial that down to about 150, because this thing actually gets slag, like molten slag on the end of it. It doesn't stay clean. As far as solder, there's nothing special about the solder. It's just that you don't want really thin solder for circuit boards. You just want some more diameter. It's tin lead rosin core. A pound of it, you use a lot of it. Terminals, electrical tape, shrink tubing, cutters, and whatever. You need all that if you were doing electric anything anyway. So that's just wanted to call that out. As far as why did I even choose lithium, the reality is that since I was going 72 volts, lead acid really wasn't even an option anymore. Where am I going to put 6 deep cycle lead acid batteries? It just really wasn't even an option. The only way this is plausible was lithium in the first place. Plus, you got to consider the weight too. It's significant. And this was still cheaper. Believe it or not, this was still cheaper. Going the Nissan Leaf batteries, you're looking at $250 plus a charger. That's way cheaper than lead acid in this case anyway. And that's usually not the case. So I think that's about it. I can go in on that. Now, how am I going to manage all this power safely? Folks, you got to use a battery management system. The current the amount that these cells can dump current wise is significant, and if you don't have any sort of way to charge these properly, you may risk overcharge on one when all the others may not be charged yet, and that's when accidents happen and lithium batteries go critical. So I got this 50 amp 20S Lithium Smart BMS from Chris at Lightspeed Bikes, the same place I got the charger. Real nice guy, was very helpful. And it's great because it has a Bluetooth connectivity, 2 temperature sensors. One I put in between the sandwich of batteries, one I put on the side. And you connect via your phone, an Android or an iPhone app, and you can monitor all sorts of amazing things, and it also makes sure that you're safe. And the other thing I didn't know is this stays connected. Even when the circuit breaker or the key switch is off, your BMS module is always running, always has power to it, even when the battery's disconnected from everything. This is wired in line with your battery stack, so it's always keeping a watchful eye on your battery pack. And I was concerned about that, the power drain, and Chris was like, well, this thing draws microamps. It'll be years before that drains your battery. I'm like, oh, okay, that's fine. Cool. So with the lithium, or with the BMS, the Bluetooth app, you can monitor, it protects you against overcharge, undercharge, short circuit, hardware overload, temperature overload, battery load undercharge. If an individual cell goes beyond a required voltage, it shuts off the whole thing. Just a host of protection parameters, and it gives you peace of mind that it will balance charge You can see the bees right here. This is during a live charge cycle. It's all real time too on your phone. This is showing that these are balanced and these aren't yet, and they're balancing them out so they charge properly. The charger was really great. I wanted something with a chunk of power. This can charge up to 12 amps. And if you got a 2.5 kilowatt battery pack, and you can charge at 12 amps, that's about 2.5 hours from completely dead battery to completely fully charged. And this is also a smart charger. This will also shut off when the current drops to a certain level, and it senses what the battery voltage is. So you've got a lot of safety mechanisms all around. It was really nice. I'm glad I spent the money on it. As far as connecting it all up, I use the red Anderson connectors because they're high current. That was I told Chris I had at Lightspeed that I had the Anderson, and he put a gray Anderson connector on. He said they were supposed to be compatible, but these red ones were Chinese knockoffs, so they didn't quite fit. So I had the gray connector that he supplied. It was really tight, so I had to grind out with a Dremel tool the middle portion a little bit so that it was more narrow, so that they everything fit. It fits perfectly. The main bus breaker, used a 50 amp marine circuit breaker, just so that you can leave everything connected, and you can flip the main bus to turn everything on, and then use your key lock on the your key with your key ignition on the dashboard to turn it on. Pretty amazing setup so far. All right, so here is everything all in the box. I was really pleased with this. I had some 1/2-inch ply. I framed up a box and got a little filing cabinet lock. Not that anybody couldn't get into it, but it just keeps it from bouncing around. Speed controllers on the back. All the protective hoses, the black flexible tubing, and everything in there. So I've got tail lights. He's got headlights, and we'll get into all the fun stuff there. So, yowzers, look at all this. Well, it just, the more you hook up, the more things you want on it. And since you have all this power at your disposal, you might as well have fun with it. I put in a buck converter, which is a DC to DC step-down converter. So it puts in up to 120 volts DC, and it's a steady 12 volt out and a 5 volt out. Looking in hindsight, as you can see, it's right here. I have a 5 amp inline fuse that goes to 12 volt supplies like your horn, your headlights, USB phone charger. Yes, he's got a USB phone charger on his go-kart. It's crazy, but this is the world we live in. Looking in hindsight, by the time you add all these things, the output I thought was 5 amps. It's only 3. And this 5 volts 1/2 amp, this is useless. There's nothing wrong with these. They work great, but it's just not. I would recommend this right here, the 5 amp out. That's a lot more adequate. That way you can, if you're charging at 2.1 amps on your cell phone, and you've got 2 amps for your headlights and taillights, and then every time you touch the horn, it's 1.8 amps burst current. You're just going to need a little to make sure you have enough. Here's the Bluetooth module. It's really cool. This is how you connect, and it's just the phone discovers it, and you bind to it, and the app launches, and it's great. Oh, very important. Okay, so the Bluetooth app. Okay, go to Bluetooth BMS, and then we'll search for Bluetooth BMS, and then you go to their main site and you go to downloads. The APK that they provide is better than what's on the Play Store. So you have to download the APK and put it in Dropbox or whatever, and allow your phone to install from that location. Because the one on Google Play Store isn't that great. It is different. So accessories, added seat belts, a forward reverse switch, this really cool power monitoring meter, a horn. So we'll show the dasher in a sec, but I'll point out that you don't really need this. This was set up. This was basically for the 1800 watt TD Pro electric motor and controller setup. All you really need is a 2-position forward reverse switch for forward and reverse. The way this set up doesn't work like it's labeled. I'll tell you how that is in a sec here. All right, so how did I get everything from the back to the front? I got this wiring harness loom. This really isn't the right one, but it was mostly correct. I was able to use most of the connectors on there, and the rest I just whacked off the connectors and hardwired all my other accessories in directly. 72 volts for the meter, 12 volt source, to bring that 12 volt source up front, everything like that. So that's pretty cool. Like I said, it's not the right thing, but I would order it again. But quite frankly, I don't know where to get the correct thing for the 72 volt solution. I couldn't find it. All right, here's the dash. Pretty slick. We've got headlights with an indicator. This really cool panel meter. To read current draw, let me go back. You have to install this bus bar right here, okay, to measure current with this shunt. Otherwise, you won't get that. That's what that comes with. So you've got 84 volts full charge. You can see it's reading accurately. He's drawn 276 watt hours, which isn't much considering he's got 2.5 kilowatts. It all kind of matches up. His runtime and how many amp hours he's used so far. He's got 32. It's about 10%-ish, 12%-ish. It's great. He's got his key switch for on-off. He's got his phone charger. All this is a cigarette lighter phone charger adapter. I broke it apart, took out the spring pin, and soldered a red and a black wire inside. So I just do that instead of buying one. Low, medium, and high. And the horn, it's just a push button horn, and I bought, it's a basic motorcycle horn. It's very loud. So the cruise. Okay. All right. So let me explain something. The cruise control only needs a momentary push button switch. This is a momentary push button switch. What does that mean? You push it, it's momentary. As soon as you let go, it goes off. I wired the cruise to this because I thought it was a switch that you would have to hold on in order for it to stay engaged. That's not the case. So stop is actually forward. I need to relabel this on the handle. With the selector in the middle, that's forward. Back is back. But forward is actually you push forward and pull. You push forward and then it engages the cruise control. So really you push forward and pull it back to the middle. That engages it. Push forward, pull it back to the middle. That disengages it. If you push forward and hold it while you're at speed, it's not like if you touch the brake in a car and it shuts off. You got to turn that off, otherwise you'll just sit there and be fighting against the motor. So to avoid that confusion, your cruise is just a push on, push off. Get a regular push button switch, but it is really cool that you can have cruise control in a go-kart. So that's pretty slick. So the cost, yowzers. So this estimate right here, this was not a gas-powered estimate. This was a 48-volt, 1,800 watt estimate, and it kept growing and growing. But when all was said and done with the 3,000 watt, 72 volt, it actually ended up being like this. So if it was a gas-powered go-kart, it'd be $700. So with electric, it was 1,700. And so even going from 48 to 72 volts, it was quite significantly more expensive, but it was worth it. The power levels are absolutely worth it. So here's the finished go-kart. It's all set, ready to roll. Getting him a phone holder so he can see his speedometer app and stuff like that. But you can buy GPS speedometers for bikes that can mount like on the steering wheel or whatever. That'd be pretty cool too. So that is the finished product. The next video will be live video, not all formal like this with a PowerPoint presentation, but just me shooting video of my son going in low, medium, and high, and then once with me doing high with the 42 sprocket, and I'll tell you how that turned out. Do a final walkthrough, so stay tuned for that. But these are all the places I got stuff: BMI, Go Power Sports, Lightspeed, battery hookup, electric scooter parts, Flaming Dirt, so on and so forth. and endless trips to Lowe's, and even Home Depot for a little few things here and there. But that's it. I hope you appreciate the video, and thanks for watching. I'm hoping that the information was worthwhile. I know that I went through this time and effort because I quite frankly hadn't seen anything like this. So I'm like, okay, this seems like this is special. I should go ahead and document it. So stay tuned for part 2. Thanks. Have a great day.